Hello guys, how are you? So if I tell you, can you eject out electron by shining light? So if I tell you, if you shine red light, green light or blue light or any frequency of light, if you shine on metal surfaces, then electron can be ejected out. And this phenomena was explained by Einstein in 1905 called the photoelectric effect, and for which he got the Nobel Prize in 1921, because by this experiment the particle nature of the light was explained, that light can behave as a wave, that all we know, because many phenomena we can explain the behavior of light by the wave theory of light, but there are certain phenomena like photoelectric effect where you need to treat light as particle. So today's video is all about that. So I will be discussing about the basic introduction of photoelectric effect, then what is the historical background, how it is developed, and how scientists failed to explain photoelectric effect until Einstein came into the picture and successfully explained the phenomena of photoelectric effect. So this is about background, then we will go to the experimental observation, and at the end we will finish with the Einstein explanation of photoelectric effect. So let me tell what is an photoelectric effect. That is the general question to our mind. So photoelectric effect, whenever a light is falling on a metal, under some certain condition electron will be ejected. So if the light has some sufficient energy, then the electrons will be ejected, and we call this electron photoelectrons, because light is photon. We will tell it later as the course goes on. So photoelectric effect, emission of electron by incident of light, as simple as that. Now what is special about light is, as you know, light we have a reflection, we have a refraction phenomena, and in the double slit experiment we have a interference phenomena of light as well, and all these phenomena can easily be explained by the wave theory of light. So this is also another phenomena where light is involved, but the observation out of this photoelectric effect cannot be explained by the wave theory of light. It completely failed to explain the wave theory of light. So question is why? Why is it so? Why the wave theory of light failed to explain this phenomena? It is the same light, it is the same electromagnetic radiation, because of this phenomena is happening. So we will explain this in this video. First of all, little bit talking about the historical background. This photoelectric effect was first observed by Henry Church in 1887. So he is a scientist who used to work with a radio transmitter, and he shone UV light on radio transmitter, and he saw that there is a electrical sparking around the radio transmitter. So that sparking happens whenever UV light is shown on the transmitter. So he couldn't understand at that time, but he observed this phenomena, and he discontinued about the explanation of why it is happening. After that, many scientists came and tried to explain this phenomena, but nobody could actually give a clear picture about photoelectric effect. So unless and until Einstein came in 1905, who successfully explained this phenomena, and the whole era changed after this explanation. What was earlier believed, what is light about? Light is a wave, light is an electromagnetic wave, it can travel with the velocity in vacuum 3 into 10⁸ meter per second. That is all true, but the nature of the light, that is what it is believed to be wave, is basically made up of wave front, and it is falling on a material. The energy will be continuously absorbed by the material. This concept was broken by the explanation of photoelectric effect. So let me introduce. So a question comes, when the light is falling, it will have its frequency or it will have its wavelength. So what is the frequency of the light or what is the wavelength? All this we need to detect. So in the photoelectric effect, there will be a simple experimental setup. There will be a quartz tube. Quartz basically is transparent like glass, but it is also transparent to UV rays as well. So there will be a evacuated chamber, that is this whole quartz tube. The vacuum, there will be a vacuum inside the quartz tube. So all the gas particle will be sucked out of the quartz tube by some rotary pump. Okay. And in the quartz tube there will be a cathode. Cathode is basically this metal which will be placed here. That will be connected to the negative terminal of the battery, and and anode will be connected to the positive terminal of the battery. And for measuring the applied voltage between the cathode and the anode, there will be a voltmeter connected it. And also to measure the current, if there is any current flow in the circuit, that can also be detected with the help of a microammeter. So the current will be in the order of microammeter. Now, so the observation is, so whenever there is a light falling on the cathode, electron will be ejected out under some certain condition. That is very important. Whatever those conditions will take into account later. So electron will be ejected out as there is a potential difference applied. So there is the electric field from positive to negative end sign, and electron will go opposite to the electric field. So electrons will be accelerated towards the anode and it will hit the anode. So because of that, there will be a current in the circuit. So whenever there is a light falling on the cathode, electron will be generated, current will be generated as well. So this current is an indication that electron has been ejected out of the metal surface, and this current is called photocurrent. So now what happens in this whole experimental setup? There were observations. So what are those observations? So observation number 1 is that, so the photoelectric effect is an instantaneous phenomenon, that is the emission of electron, so it is an instantaneous phenomena. That means as soon as the light is falling on the metal surface, if it has sufficient energy, electron will be ejected out of the metal surface. And in the experimental setup, because of the restriction, the time can be measured as 10 to the power minus 9 seconds. So this is a very fast time, this is a very small time. Within this time, electron will be almost immediately ejected. Why it is so, we will explain in the later case. So this is one point, something which the wave theory cannot really explain, because in wave theory it was believed that whenever light is falling on a material, it will distribute the energy in continuous fashion throughout the material. So the electrons in the material, it will absorb the energy and it will take some time to reach sufficient energy, then only electrons will be ejected out. Let's say if you are using a less intensity of light, it is supposed that the energy will be less and the electron will acquire some time to eject out of the electron. But that is what is not the case in the experimental setup. This is absolutely an instantaneous process. So what is happening here? Why the wave theory is failing to explain this process? We will come into that picture later. Second thing is the kinetic energy. When the electron is emitting from the metal surface, it will have some kinetic energy. Those kinetic energy maximum, this does not depend on the intensity of the light. So kinetic energy maximum does not So the kinetic energy does not depend on the intensity of the light, but this kinetic energy depends on the frequency of the light. For the case, if you use a blue light instead of a red light, blue light will provide more energy compared to the red light, because a blue light has higher frequency. Higher the frequency, higher will be the kinetic energy of the emitted electrons. And you can actually measure this kinetic energy by applying some potential. How to do that? To do that, you reverse the polarity of this power source, variable power source. So now this is your negative terminal and this is your positive terminal. Okay. So now the cathode is connected to the positive terminal. Positive terminal. So there will be now negative potential coming here, and this will be positive. So now electrons are ejecting out of the metal surface. It is trying to go towards the anode, but I want to measure a voltage for which the electrons cannot go here. That means I want a voltage V0 for which current is almost 0 in the circuit. Okay. So electrons, if it has sufficient energy, it will try to move to the anode, but there is a negative potential applied here, so it will repel the electron. So if it is if the kinetic energy is very large, it can reach the anode irrespective of the potential is negative. But slowly you will increase the potential from 0 to some value, so that none of the electrons can come to the anode. Therefore the current in the circuit will be 0. So you can say that your kinetic energy maxima will be equal to EV0. I am using maxima here because the energy of the electrons will be lying in a range. All the electrons will not move with the same velocity. So stopping potential is some potential which is sufficient to stop the maximum energetic electrons also. That means there will be absolutely no current flowing in the circuit. That is why we use kinetic energy maxima. This is important. Okay. So this is one equation. Now what are the third observation? Third observation was that if you shine any kind of light, will the electron be ejected? It was observed that there is a particular frequency for every metal. So if you use an incident light above that frequency only, then only electron will be ejected. So the frequency of the incident light must be greater than some incident frequency, or this is known as the cutoff frequency. Then only there will be emission of electron. And your current will be non-zero. But if the incident frequency is less than your cutoff frequency, there will be no emission. No emission. So therefore the current will be 0 in the circuit. So these are phenomena. So let me draw some graphs to explain the complete scenario here. So let me first draw what is the relationship between the photocurrent and the applied voltage for different intensity of light. Let's say I am using a red light. Let's say I am shining a red light here. Okay, and the intensity is constant initially. So I started with a red light. The intensity is like this. So for a particular intensity, there will be particular current flowing in the circuit. Now if you slowly decrease the potential and it will reverse the potential and it will make it 0, then you change the polarity, then you will touch on the negative x-axis of the voltage where the current will be 0. So this is what the stopping potential. Let us denote it by minus V0. This is for intensity I. Similarly, if you draw for higher intensity of light, so this is 2I and this is your 3I. So if you are increasing the intensity of light, you can find the photocurrent maxima is increasing with the intensity of light, but the current will be 0 for the same stopping potential. It is because though the intensity of light is more, the energy of the emitted electrons will still be same, because intensity means there is something which I will come into later picture when I will explain the quantum theory of light. So this is the case. So the observation is, if the intensity is more, current will be higher, but their kinetic energy max will be same. So the stopping potential will be same. So stopping potential does not depend on the intensity of light. This is another observation. What is next? Next is, instead of red light, now if you use three kind of light. Now say let's say you use a blue light. So now in this scenario I will use blue light. I will use a red light. And say I will also use green light. Take this as green light. So green red and blue light. So all the light will be having same intensity. Intensity by means how the light is glowing. The glowing for all the light will be same. I will use the same power to glow the light. Okay. So if the intensity is same, we know from the previous study that the maximum photo current will be same for all the cases. So this is be same. But what happens is that for blue light you will need higher potential, stopping potential in case of blue light, V0, let us just call blue. But in case of green light, though I have a black marker, but let us assume that this is a green light. So in case of green light, the stopping potential will be little bit less, and in case of red light you need less stopping potential. So this is your minus V0 red, and this is your minus V0 green. So your actually V0 blue is higher than V0 green and then the V0 red. This is your IP versus P. So that means if you are using a higher frequency of light, the emitted kinetic energy of the electrons will be more, and you need to stop that electron. You will need to use a higher potential difference across the anode. Okay. So this is the scenario here. Now what was the explanation given by Einstein? So let me remove these observation parts. So before Einstein, it was Max Planck who gave the idea that whenever energy is emitting from a black body, the emitted energy will have a discrete nature. That means energy will not be continuous. It cannot have any specified value. It will have certain value. So if the energy is emitting, the energy can be 0, h nu, 2h nu, and so on. So Einstein take that idea, and Einstein told that light is nothing but some kind of stream of particles which are known as photons. So light consists of photons, and these photons carry out energy in bunches or in bundles. So it can carry energy in certain values. So if energy of photon, we can write as n h nu, and n can be 0, 1, 2, 3 and so on. So energy of a photon will be denoted by Planck's constant multiplied by the frequency of light. Okay. So higher will be the frequency of light, higher will be the energy for the photon. So now the complete picture of this scenario must be removed. So we have to think of that light is now not is a wave, it is not behaving as a wave, but light is behaving as a particle. Let's say light is consisting of some particle and particle is falling on it. So this is the scenario. Now the picture, why it is instantaneous process. So it is because whenever light, that means stream of photons, if it is falling on the metal surface and if it has sufficient energy, then it will share the energy with the electron, and this electron will be ejected out. So it is just an instantaneous process. Remember, imagine that you are moving at a very fast velocity and your friend is standing still in some barrier, and you collide with the friend immediately. So within a fraction of time, within a nanosecond regime, your friend will be deflected. So same scenario is happening here. Okay, so this is the case. Now Einstein gave an equation. He told that the energy of the photon will be shared with the electrons. The energy will be shared in the metal. Some part of the energy will be absorbed by the work function of the metal. I will tell what is work function is, and the rest of the energy will go to provide kinetic energy of the electron. So I will have kinetic energy max. Okay. So this is one Einstein equation. So this phi 0 is nothing but work function of the metal. Okay. So what is work function? Work function is the minimum energy required to free the electrons out of the metal surface. So you know, in a metal electrons are free, right? So I have a metal, so inside electrons will be free. Let's just think that electrons are randomly moving. So it can be free inside this barrier, but it cannot come out of it. But if you provide some sufficient energy to this electron, then these electrons can eject out this of this metal surface. So it can, you can say, leak from here. Okay. So think of a scenario, you are having a birthday party with your friends, and your parents have just closed the door and put you restriction that whatever you want to do, you can do inside your home, but you cannot come out of the house. So that is you are free in the home, just like electron in the metal, but you cannot come out of the house. That is you cannot come out of the barrier. So electron having some kind of barrier inside the metal. But if you provide some energy, let's say your parents come back and they open the door for you, then you can immediately, you are free and you are free to go. So in the same case, work function in a metal is a minimum energy that is to be provided to the electron so that the electron can become free of the metal surface. So if you provide some energy which is let's say energy which is equal to this work function, then the electrons which are inside the metal, they will just become free to come on the surface. Okay. So this is the thing. So this is the minimum required energy to make the electron free. So now what are the another forms of this equation? So you can rewrite this equation as kinetic energy max is equal to h nu minus phi 0. Now what is phi 0? Phi 0 can be written as h of nu 0. So nu 0 is some cutoff frequency, so there will be some minimum energy that is required to free the electron. So this is h nu 0. So you can put on this equation h nu minus h nu 0. This is your kinetic energy max. Okay. Now you can also substitute this kinetic energy max by EV0. So now your EV0 is h nu minus h nu 0, or your V0 is h by E minus nu minus h by E nu 0. Now look at this equation. This is just a equation of straight line like y equal to mx plus c. So if you plot a graph of y with respect to x, it will be a straight line and m will be the slope. So let us plot this scenario here. So you have a V0 in y axis and frequency in the x axis. So for a particular frequency nu 0, now if you increase the frequency, then the energy of the photons or the energy of the light will be increased. So the stopping potential will also increase like this. Okay. If this is for one kind of metal, let's say it is for metal A, then for metal B, let's say it is some another nu 0, let's say it's nu 0 A, then nu 0 B, then obviously your nu 0 B is greater than nu 0 A. That means if nu 0 is 0 B is greater than, then for the metal B, the work function is more. That means for the metal B to eject out the electrons, you need more incident energy. Okay. So now from this curve, one thing is interesting is that if you extend this line to the negative axis, then there you will have an intercept. This intercept is nothing but your h nu minus h e by e0. Okay. Or you can measure the slope also. So from the slope, which is the slope in this equation, that is h by e. So let me just draw a line here. So slope is equal to h by e. So this is actually very famous equation. It is very useful in measuring the Planck's constant. So if you can draw the curve, stopping potential versus the frequency of incident light, then actually you will get a straight line for a particular metal. Okay. And if you really measure the slope, then you can calculate the Planck's constant. So electronic charge, if it is known. Okay. So this is what a photoelectric effect is. So now the complete picture has changed now. Light was wave, but this scenario is now successfully explained if we assume that light is not a wave, but it is consisting of particles called the photons. Okay, and this photon can carry energy in bunch or in bundles. It will have some allowed energies, and all these photons will hit the electrons in the metal surface, and the electrons will immediately take those energy, and it will further be emitted. Those electrons can have collision in the metal surface before coming out. So the electrons which are very near to the surface, they will be taking this energy, and they will be emitted. Okay. So thereby this kinetic energy maximum also come into the picture, because all the electrons energy will not be same, because this kinetic energy maximum will have a range from h nu to minus h nu 0. Okay. So this is all about photoelectric effect. Now as you have seen that with the intensity of light, the value of the photocurrent is increasing. So this can also be explained by the quantum theory. If you treat light as particle stream of photons, so by more intensity of light means more number of photon is falling on the metal surface. So thereby photon will hit the electron, and the electron will be ejected out. If there are more number of photons, then the collision or the energy sharing with the electron will be more. So in that process, more number of electrons will be ejected, but their kinetic energy maximum will be same for all the cases. So more intensity means more number of photon from the incident radiation is coming. Less intensity means less number of photon is falling on the metal surface. So that's it for today. I guess you got some idea about this photoelectric effect in a simpler way. So I'll be coming back with another video very soon, though this video took a very long time for me. So as you know, there are exams coming on based on interview in BARC or radiation physics. So I'll come back with many more videos very soon, maybe by the end of this week, so that you can have idea in radiation physics what type of questions being asked after you clear the written examination in the interview.